Hi guys, welcome to the next lecture of this series. I'm going to talk about even and odd functions today. Let's first understand when is a function even? When is a function called an even function? So suppose you have y equals to fx as a function. It is called even if something particular happens. Now, what's that particular thing? So a function is even in case if you put the input instead of x, the input is minus x. The value of the function is the same. So if f of x is equal to f of minus x, that is x and minus x, they are both generating the same value. For every x this is happening in the domain of f, we call that function an even function. For example, so if I take fx as the most common example for you to understand, to be able to understand this kind of concept is x squared. Suppose I take the function as x squared. You know it's a parabola, right? You know it's a parabola. And if I observe the value of this function at some value minus x, at some input minus x, it's going to be minus x whole square. Now, minus x whole square, when you are squaring, you're going to get the same value, x square. So, which means f of x is equal to f of minus x. And it's going to happen for every x in the domain because I've taken a general case here, right? So, it's going to happen for every value in the domain. You can even observe that graphically. So the graph of x square will look something of this sort, right? And if you observe, suppose this is 1 and this is minus 1. So I'm going to just make this vertical line here, this horizontal line, and now the vertical line. So suppose this is 1 and this is minus 1. What's going to happen with the value? The value of the function is the same, right? It's a 20-to-1 function clearly. So f of 1 is equal to f of minus 1 because it's going to be just equal to 1. F of 2 is equal to f of minus 2, and that's going to be 4. So similarly for other x's as well. This is what an even function. If you replace the input by minus of that, you're going to get the same functional value, and then you call that function an even function. Now comes the next terminology. What is an odd function? Okay, so an odd function is a function where if the input instead of x is minus x, then the functional value is also negative of the same value. That is, y is equal to fx, suppose, is a function. This function will be called odd if f of minus x, if you put the input instead of x, you put the input minus x, minus of f of x is what you get as a result. And that's happening for all x belonging to the domain of this function. Then this function is called an odd function. A very good example of an odd function could be if I take the function y equals to x. So the graph of y equals to x goes something like this. You have f of 1 is just 1. F of 2 is just 2. F of minus 1 is minus 1. F of minus 2 is minus 2, and so on and so forth. So a line like this. So it's a linear function, of course. So you get a line passing through. It's a 45-degree line passing through the origin, right? 45-degree line passing through the origin. Now, what's going to happen here? F of 1 is 1. F of minus 1 is minus 1, which is actually equal to minus of f of 1. F of 2 is 2. F of minus 2 is minus of 2, that is equal to minus of f of 2, I can say, and so on and so forth for every value in the domain. This will happen. This kind of a function is called an odd function. Now let's try and figure out whether the following functions are odd or even. The first function I'm starting off with, let's take f of x as 3 times x square minus 4. You can figure out whether it's even or odd graphically or numerically, whichever way you want to. I'm going to first of all take a general case. What happens to this function in case I take up the input instead of x as minus x? So f of minus x is something that I'm going to evaluate. It's going to be 3 times minus x whole square minus 4, which means that I get 3x square minus 4, which is nothing but f of x, right? So I just have f of x as, which is equal to f of minus x. And this is what you require to figure out whether the function is even. Clearly, this function is an even function. Second question, I would like to check whether f of x equal to 1 upon 2 times x is odd or even. Well, we would like to check what kind of a behavior is f of minus x following. So f of minus x would be 1 upon 2 into minus x, or in other words, it is minus 1 upon 2x, or in other words, it's minus of f of x itself. And that's the general case I've taken again. Now, what have we realized here? F of minus x is giving you, the output that comes out is minus of fx. And that's what happens when a function is an odd function. So this function clearly is an odd function. Let's take another example to be clear on this concept. So let me take fx equal to x cubed minus x square. Taking x cubed minus x square, I am interested in the behavior of f of minus x, right? So f of minus x will be minus x whole cube minus of minus x square. So that's going to give me, now when you cube minus x, you will again get minus x, minus outside. So you will get minus x cube. So it's like multiplying minus x, minus x, minus x. So you're multiplying minus x 3 times basically. So you will have a negative sign and x has been multiplied 3 times. So you will have minus x cube. Minus of, now you are multiplying minus x 2 times. So you'll have a positive value. So it's just going to be x square. So which means that what do I have? I have minus x cube minus x square. So am I getting f of x itself, or am I getting minus of f of x? Well, seems like both the things are not happening here. This is a kind of function which is neither even nor odd in the whole domain. You cannot say it's even because f of minus x is not turning out to be f of x for all x's. You cannot even say that it's an odd function because f of minus x is not turning out to be minus of fx for all x's. Below what you can see here on the screen is a part of a particular graph. So suppose you have a part of a graph. Can you say that this is an odd function or an even function? Or in other words, can you create an even function out of it? Can you create an odd function out of it? Absolutely, yes. So now I'm going to extend this as an even function and as well as an odd function. How we can do that? So even function, what does it require? It requires that the functional value at x and minus x is exactly the same. Right? That's what it tells you. If that will be the scenario, then suppose this is some particular value. Say this is x. And if we go exactly this much here, this will be minus x. So what do I require? I require the graph has to be like a replica on this side because the values have to match. So if you're this much here, you're going to be this much vertically here also. And so on and so forth. And so on and so forth. So create a replica graph here, and that would mean that you have just created an even function out of this part of a function. So an even function created out of this part of the graph will look like this, because what's going to happen here is that you will have exactly same amount getting generated as an output as, for x and minus x. To construct an odd function out of this part, suppose this is the part given to me. Now I want to construct odd function. What is the requirement for odd function? The requirement is that in case if this is f of this is x and this is f of x, so this vertical amount, okay, this much length is getting generated, okay. So for minus x also, this much of length should get generated. That's what is the meaning of an odd function. So if I have to do that for every value, I got to get the replica like that. So if this much vertical is here, then for x here, this much vertical is here, and so on and so forth. So that would mean that I have a replica graph moving down here, exactly the same sort of shape down here, which would look something of this sort, okay? Of course, if you take a proper, unit graph, then it would be a more, proper picture. But this is what it basically means. In the red, I have created an even function. In the purple, I have created an odd function out of a part of graph that I had. So I had f of x with me, and I generated f of minus x in such a way that I could get an even function out of it, an odd function out of it, and graphically, this is what is the difference between the two things. Kindly note down some special properties regarding odd and even function. Number one, so the sum of two even functions will always be an even function. Sum of two odd functions is always an odd function. Sum of an even function and an odd function is neither even nor odd. Now, talking about product of two even functions is always an even function. Suppose you take x square multiplied by x square itself, you will get x to the power 4, again an even function. The product of two odd functions is also an even function. Suppose we take the function as x multiplied by x will give you x squared. So that's an even function, right? The product of an even and an odd function is actually an odd function. Suppose you take x squared as an even function and x as an odd function. So x squared multiplied by x will give you x cubed. That will be an odd function, and this is going to happen always. So these are the general properties that you must know about an odd and an even function. Lastly, graphically speaking, an even function is symmetric. The graph is symmetric about the y-axis. Always remember the graph of y equals to x squared, and you will be able to recall this property. An odd function is symmetric about the origin. Always remember the graph of y equals to x, and you will realize what I am saying, because f of minus x, for any minus x, you will get minus of fx as the functional value coming out, and hence symmetric about origin. Thank you.